In this video, I want to talk about three concepts. The first one is critical value. The second one is the type 1 error. And the third one is the type 2 error. Now, we'll start with the critical value. Okay, I'm just drawing out a null distribution. Let's say it is approximately a normal distribution. And right here in the middle, we have the mean. Okay. Now, earlier in the previous video, we talked about significance level, right? Significance level is a percentage that we define at the beginning of our experiment. So, for example, if we have we represent it as alpha. Suppose we have defined the significance level of 5%. Okay, and what we are saying is, if the test statistic, that is the p-value, is less than the significance level of 5%, then we're going to reject the null hypothesis, because there's evidence that the new theory that the scientists came up with is valid. Okay, so if I wanted to express the significance level on this graph, I would write it as this line here represents the critical value, and this area here represents the rejection region. So if your p-value lies within the rejection region, then you reject the null hypothesis. And this unshaded portion on the other side is the acceptance region, where you accept the null hypothesis and discard the new theory that your scientists came up with. So this line that separates the line between acceptance and rejection represents the value or the critical value. Okay, so that is your critical value. So if the p-value is greater than the significance level, then you accept the null hypothesis. So your rejection region is x less than the critical value, and or less than equal to your critical value, and your acceptance region is x greater than the critical value. And we keep in mind that the shaded portion is based on the preset significance level, alpha. Next concept we want to cover is are the errors. So the first one is called the type 1 error. When do you have a type 1 error? You have a type 1 error when you reject a true null hypothesis. Means your hypothesis, your original hypothesis, the null hypothesis is true, but you mistakenly reject it and keep your alternative hypothesis and believe that to be true. Okay, so it's called a type 1 error, and the calculation for a type 1 error, or the probability of a type 1 error, is equal to the rejection region, or the probability represented by the rejection region. So in our example up here, it's going to be probability that x is less than or equal to xc. Now, for a binomial distribution, this value might be slightly less than the significance level because a binomial distribution uses discrete values. If you're using a normal distribution, then the rejection region or the probability of a type 1 error is exactly the same as the significance level. Okay, so the next thing we want to talk about is the second type of error, which is the type 2 error. In a type 2 error, we end up accepting a false null hypothesis. Meaning the null hypothesis does not hold, but we end up accepting it and we discard the new alternative hypothesis. So the calculation for a type 2 error is like this. Probability of a type 2 error would be the probability of the acceptance region in the true null distribution. We can also write it as probability of acceptance given a new null hypothesis. Okay, I'm going to show you how to do all of these calculations in the next section where I solve some past papers.